Okay, class, we're going to discuss homework sets 1 and 2. Homework 1, of course, is particularly simple. Using the tables in the book, there's obviously a big difference between the water consumption in Ohio and in Nevada. So you can see a large difference. Problem number 2 requires you to interpret the chart to get the maximum and the minimum values and the average values. Now I put the values here in meters per second simply because the flow rate is instantaneous rather than on a daily basis. Most of you put the flow rate in terms of meters cubed per day, which is acceptable, and I didn't deduct anything for that. Also, the charts we're looking at are pretty difficult to interpret, so I never took any penalty for somebody's guess about what the ratio was. So here we have the balance of the equation there. So continuing on with homework set number 2, conceptual design. Essentially, the conceptual design is where most of the major decisions are made, and it's very important to get these established, the location and the water source, the water quality specifications, and also it's very important to identify what aspects are unknown so that they can be developed early on in the project. Okay, why are secondary standards important? Because primarily these are aspects of water quality that are aesthetic, such as taste and odor, and they're not necessarily highly critical with respect to health and safety. Okay, the rationale, what is the permit number? It's clearly easily found on that page. What are the BOD limits? They're expressed in terms of mass. Those are also on this page. Some of you calculated those values. Nothing wrong with that, as long as you get the right number. Okay. Question number 5. The TRC limits. I had a little typo there, so I intended to ask for the daily maximum. That's not a problem. The water quality limits are clear. The zinc limits for salt and freshwater I think are very interesting. You'll note that the limit is quite low, 37 parts per billion in freshwater, although it's somewhat higher in salt water or brackish water, which is because of much higher hardness of those streams. Okay, fresh FWs, obviously freshwater, ONWR, outstanding natural resource water, and shellfish harvesting water. Easily found in that reference. The pH and DO standards are here. And on the equations, you can see that the textbook, in this case, has a couple of glaring errors. And as you go through this book, you'll find more if you are very diligent with your calculations. So, and that's true, I think, of almost any work by almost any author. So just keep in mind that, and if things don't really look right, it's always a good idea to ask questions. So I will generally be posting the solutions to the homeworks and the exam as quickly as possible after the work is done. This case has been delayed because some students have been delayed in submitting their work. I hope this is helpful for your preparation for the exam.